In this section, we're going to take a look at how to solve inequalities in two variables now. In the first three sections of chapter 9, we actually looked at inequalities that had only one variable in it. So now we're going to look at the case where we have two variables. When we graph the ones with one variable, remember the solution was a segment on the number line. A shaded region, if you will, a shaded segment on the number line. Well, with two variables, we're still going to shade a region, except it's going to be a region in the two-dimensional plane. Okay, so let's begin by working actually an example and see how this is going to work out. Okay, so I went ahead and inserted a rectangular grid on the page so we can actually graph these a little more accurately rather than me doing it by hand. Okay, now graphing linear equations. Hopefully all of you remember how to graph linear equations. The easiest way probably is by plotting points, right? So this is what we mean by plotting points. You choose a number for x or y and you solve for the other variable. And all we need is really 2 points, right? For any straight line, we need 2 points. You connect the points together and then we draw that line. So for example, I'm going to let x be 0. When x is 0, plug in for x 0 in here, so we get 0 plus 3, and that's going to be 3. Y is going to be 3. Okay, now I just need one more point, right? So if you want, let x be 2. When x is 2, 2 plus 3 makes 5. And there I got my 2 points. So my points were 0, 3, right? 0, 3, that's this one, right? That would be the y-intercept. And the other one is 2, 5. So when x is 2, y would be 5. That's this point, right? And then we can draw the line right through those two. So let me grab my double-headed shape arrow here and see if I can draw this thing. And so we're going to draw the line from here to here, and there you go. We're going to extend it, and that's going to be the line. Okay, so that's how you're going to do this. There you go. And again, you can extend this to however far you like, as long as we have a reasonable graph. And there you go. So that's going to be the graph of the line. Now, one thing we gotta be careful with here is this. There's nothing wrong with the line. That's how you graph the line, right? Now, if you look at the points that's on the line, so for example, a point here and a point here. Okay, remember 0, 3, the ordered pair 0, 3 is a point, so it's 2, 5. Let me actually plug in a 0, 3 into inequality, see what happens. When y is 3, x is 0, and that means 3 is less than 3. Now, this is not a true statement, is it? It's false, because 3 is equal to, not less than. So that means the y-intercept, which is a point on the graph, is actually not a solution. We run into exact same thing with the other point that we plotted, the 2, 5. That would also, when you plug in a 2 for x, 5 for y, you get 5 is less than 5. So neither of those are going to give me a solution. So that suggests that all the points on the line, they're going to give me a false statement. Therefore, none of the points on the line are actually going to work, right? So what we do in that case is we actually create and make this, turn it into a dashed or broken line. And that's what the significance of the broken line is. Means the points that are on the line are not going to be part of the solution. Okay. Wonder if I can get a broken line. No, I don't have it here. That's fine. Now, here's how we haven't accounted for less than, right? The inequality. So at this point now, we're going to actually account for the inequality. Here's how we do this. Our next step is to choose a test point. Okay. Now, a test point is a point of your choosing. In fact, you pick both x and the y. So, the only restriction is you cannot pick the points that are on the line itself. Okay, so any other point is fine. Usually, my favorite test point is right here, this one, the origin. Okay, which I exaggerated, but here you go. This is my test point. Call that TP, test point. So I'm going to go 0, 0. Now what we're going to do is we're going to plug in for x0, for y0 in the original up here. Okay, original inequality. So this is going to make it y0 less than 0 plus 3. Left side 0, the right 0 plus 3 is 3, and then we test again the truth or fallacy of this statement. Is 0 less than 3? Yes, it is. So this is true. So your test point is actually turns out to be a proposed solution to the inequality. That's what that test point is. It's a random guess at the solution. Now, once we get a true statement, means yes, that is a solution, a working solution. And because that working solution, 0, 0, lies below the line, then that means every point below the line is going to work. All of these are going to be solutions. So there's going to be infinitely many solutions, right? So the answer in this section to our inequalities are going to be a shaded region on the plane. Okay, so there you go. We're done with this. Again, this solution is a visual, and we're done with that one. Number 14. Let's take a look at another one. For example, in number 20. Number 20, I have 3x plus 4y is less than or equal 12. Now, for an equation that is in general or standard form, which is what this is, meaning x and y are on the same side, usually here's how I do this. I plot the intercepts. So I'm going to let x be 0, and then separately I'm going to let the y be 0. Okay, and that's what we mean by intercepts. So when x is 0, you practically ignore this term, and the inequality or the equation is 4y equal 12. Don't worry about the inequality. We always start as if this is a line and ignore the inequality. So 0, 3 is a point on the graph of this line. True? Now let's try 0 in for y. 0 in for y, so I have 3x. Again, 0 times 4 is 0, so 3x is equal to 12. And remember, you always work with setting this as an equation of a line equal to, regardless of what the inequality says or reads. Divide both sides by 3, and this gives you 4. So there you go. We got our 2 points. The easiest points you can find. Okay. Now, I need to graph these 2 points and plot the line, right? Or graph the line. Okay, so I went ahead and inserted my coordinate system. So I'm plotting 0, 3. Point 0, 3 is going to be this point, the y-intercept. And 4, 0 is actually the x-intercept. Now, I'm going to draw the line that I did before, this time through these 2 points. So it's going to be this one and this one. And then I can extend these in both directions just to have a line. And this one, drag it in this direction. So there you have it. If you want, you can actually go all the way to the grid, however far, it doesn't matter. Okay, now this time if you do plug in 0, 3, for example, into the inequality, it's going to be 3 times 0 plus 4 times 3 less than or equal 12. So that's 0 plus 12 less than or equal 12. 12 less than or equal to 12. Now this one is actually a true statement, isn't it? So all the points on the line now are going to be true. So this line is going to be a solid line. Okay, so we have already infinitely many solutions, all the points on the line. Now to account for the inequality, we need to choose a test point. And again, my favorite test point is 0, 0. The only time the 0, 0 doesn't work, by the way, that is this point, the origin. The only time it doesn't work is if the line goes through the origin, because remember, we're not allowed to pick points on the line for our test points. And when that happens, so for example, let's say I have a line that goes right here like that, and I cannot pick 0, 0. Then the next smartest point to pick is either 1, 0 or this one, or 0, 1. So if you have a line that runs through the origin, remember, those are your test points. 1, 0, 0, 1. And that would be the best test points you can find. And of course, you can try any test point. We all get the same ultimate shading. Okay, so here's 0, 0. Let's plug him in into inequality. That means 3 times 0 plus 4 times 0 is that less than or equal 12. And this time, let's see, we get 0 less than or equal 12. This is true. Again, if this is true, that means below the line, right in here, we have a true statement. So that means I need to shade below the line, because our test point gave me a true. Again, right in here, my test point right in here give me a true statement, means that is a solution. So if it's a solution, therefore we can now shade below the line, and all of this is going to be a solution to this inequality. And there you have it. Okay, we're good with number 20. With that, let's go to something like number 26. Let's look at a couple of special lines. Number 26x. Oops, don't know what I did. Okay, x is greater than or equal to 3. Now, x equal to a constant, if you remember again from your earlier days in algebra 1, x equal a constant is going to be a vertical line at the value of the constant. So for this one, instead of using the grid, I'm just gonna draw a vertical line at 3. And there you go, that's my rectangular coordinate system. So the vertical line is x equal 3. Now x greater than 3 means everything above the 3 is greater than 3. So there you go, that's the answer to that one. So it did require we remember x equal 3 is a vertical line at 3. We didn't plot points. Number 28, I have y is less than -1. So for this one, we're going to have a horizontal line. We just had a vertical. Y equal the constant is going to be a horizontal line at the value of the constant. This is at -1. And because the inequality is less than, for that reason, the line is going to be a broken line or a dotted line or a dashed line there. Next, we need a test point, right? Or you can say, well, y less than -1. Well, less than -1 would be like -2, -3, and so on, right? So I'm going to shade all of that. If you want, you can pick a test point 0, 0. You plug in a 0, you get 0 less than -1. And that is false. 0 is bigger than -1. It's false, so my test point actually is not a working solution. Therefore, we're going to remove it. I mean, we're not going to shade or include it in our shaded region. Remember, if the test point gives you a true statement, you want to include it in the solution inside of the region. If the test point gives you a false inequality statement, then you do not want to include it. So there's number 28, and let's take a look at something like number 33. In number 33, I have y line between 0 and 3. So remember, y equals a constant is a horizontal line at the value of the constant. So in this case, this is y equals 0. And up here, let's say that's y equals 3. We want to be between 0 and 3, right? Y between 0 and 3. Everything here is between 0 and 3, right? And all the way to the other side. And it would be a solid line because you have equal sign. And there you have it for number 33. Okay. Now let's take a look at a system. So I was going to do a couple of more. That's why I have these grids all ready to roll. They're both lined up. Go to task. Okay. So let's take a look at exercise. I'm trying to pick something interesting. Let's begin with let's say we're going to do number 46. Okay, number 46. I have x plus y is less than 1 and x negative y is less than 2. So here's my system. Now let's do the first one. This is a system of linear inequality. So we're going to follow the same process as we did up until now, except we're going to graph two inequalities on the same coordinate system. So let's begin with the first one. I'm looking at x plus y equal 1. We're going to plot points, right? And we're going to pick smart points. When x is 0, y 1. When y is 0, x is 1. And the other one is x minus y equals 2. See, I'm ignoring the inequalities. And plot points for this one. X is 0, then separately y 0. When x is 0, that's gone. You just have negative y equal to 2, so y must be negative 2. True? And when y is 0, x must be 2. Okay, so now I can actually graph these two lines. Okay, so the first one, this one, is 0, 1. Now, 0, 1 is that point, the y-intercept. And 1, 0 is this one. So let me again get my shapes out and graph this line. That's going to be this one and this one. So now let me extend it in this direction and extend it in the other direction. There you go. So that is the line. Right? I know it's off a little, folks. I know. And it looked good when I tried it earlier, but let me see. 0, 1, 1, 0 is right here. Maybe because there I moved it away. 0, 1, 1, 0. There you go. That's it. We got it. Okay, what was throwing me off were these two dots. Okay, now that looks good. Okay, this time again, this is going to be a broken line, correct? In fact, both of these lines are going to be dotted lines, broken lines, because we have less than. With less than and greater than, it's going to be a broken line. Now let's do our test point for our first line. 0, 0, fine. Doesn't go through the origin, so I'm okay to pick it. 0 for x, 0 for y is less than 1. 0 is less than 1. That is true. 0 is less than 1, right? So we're going to shade below the line. Now, so that means I'm going to go in this direction. Okay, so there's my shading. Now let's draw the second line. For this second line, it's 0, -2, so 0, -2 would be this point. And the other one is x is 2, y is 0. That's this point. And I'm going to extend it in this direction and extend this one in this direction. Okay. And I make it, let's make that, I don't know, what color should it be? Blue? Yeah, why not? And this line, we make that green line. Ooh, that looks nice. It really does look broken line. So is the other one, right? The other one is broken line too. This blue line must be a broken line because it's less than. Good. Now let's do a test point for this one. Again, 0, 0 is fine. And 0 minus 0 is less than 2. 0 is less than 2. And that is true also. So that means the origin is a solution to this one. Now, the shading for this one, let me shade it in, I don't know, green, what do you say? Or blue. Let's stay with blue. Yeah, that's fine. So I'm going to shade everything. Notice the origin just got included. And there is a shading. Now, where do you think the solution is? Remember, solution must work in both of them, right? So it looks like the crosshatch is the common region of intersection. So everything in here is going to work. That's going to be the solution to this inequality. And there you go. That is a solution. Okay. And there you have it. Number 46. And let's do one last one and we'll be done with this section. Okay, so for this last example, let's take a look at how about let me try number 38. This is a little different. Number 38, in that the first equation, y is greater than x, there's no constant there, and y less than or equal to negative x plus 4. Okay, now first one, y equal x, x, y, x is 0. When x is 0, well, y must be 0. So it doesn't make sense now for me to say when y is 0, because then I get x is 0 is the same point. Now, then that's the case. The next one, it's easy. I'm going to let x be 2. When x is 2, y is 2. X and y are the same. So, and then my test point. Let's see. Let me graph the line for you first. Okay, 0, 0 is right here. And, hold on. That's... let me actually remove this one. I don't know what happened. Okay, so let's start this again. So I'm gonna go 0, 0 first. Okay, so this is 0, 0, and then the other side of it is 2, 2. I'm gonna grab this and go on to 2, and 2 is here, right? There you go. And x is equal to y, so you get this 40-degree angle that bisects the quadrants. Okay, and there you have it. Both of these lines will be solid lines, right? Because of equal sign. Now, my test point, see, I cannot pick 0, 0 because the line does go through 0, 0. So we can pick anything. There you go. How about this one? 4, 0. That's my test point. Just to be different. Now 4, 0. And you're going to plug this into your inequality. 0. I'm going in here, right up there. So y is 0 greater than x is 4. Is 0 bigger than 4? No. Therefore, 4, 0, my test point, my proposed solution actually will not work. Since it will not work, I'm going to shade above the line. Okay, everything up here will work. So remember, if it's false, your test point is false. You want to shade away from it. Now let's do y equal negative x plus 4 to graph the second line. I'm going to plot points on this one. When x is 0, y 4. I'm going to let, right, when x is 0, y 4. And when x is 4, y should be 0. Because you get negative 4 and 4, 0. Ooh, how coincidental. My test point was 4, 0. Okay, let me remove it. Now, let's plot these points. 0, 4 is here, and then 4, 0 is here. So I'm going to go grab my auto shapes and go here, and then the other side of that is 4, 0. There. And that part, and again this part goes through 0, 4. Okay, right there. I'm gonna make that a red line and solid red line. Okay, now let's do our test point. So my test point, again, it doesn't go through the origin, so I'm back to 0, 0. 0 less than or equal to negative 0 plus 4. 0 is less than or equal to 4. 0 is less than 4, right? Not equal, but less than is good enough. This is true. So now the origin is our test point. This point is actually a solution with respect to the red. So I'm just going to also make my shading in red. See, I just passed the origin. The test point is included. So what is the solution to this one? The region of crosshatch is going to be this conical region right here. True? There, above this black line and below this red line, and right there. And let me make this line maybe a heavy. Whoa, that's heavy. I'm gonna make this one. I like that one. Let's make this one also. That's fine. That's good, because I was gonna make it again too heavy. That's good. You follow. And there you go. So hopefully you followed everything we did here. And with that, we are done with this section. So in this section, again, we talked about inequalities in two variables. Your solutions are all going to be graphical solutions. And we are done with the section.